Good evening. This is another circle theorem. This is 2018, paper 3. This is question number 12. All right. We have this right here. And we are only given one angle, right, over here, right? So we're going to use theorem number 7. It states that from any point in space, only two tangents can be drawn and are equal. So if I draw a tangent here and a tangent here, that means that they're equal in length. What does that mean? This is an isosceles triangle. Therefore, these two angles must be the same. If this is M, this must also be M. See that? Good. So now I got 58 plus 2M is equal to 180. This is now a two-step linear equation. Subtract 58 from both sides. I get 2M is equal to 122. Divide by 2, I get M is equal to 61 degrees. If M is 61 degrees, that's 61, and that's 61, right? Good. All right, M is equal to 61. All right, now let's find N. Now we can use another theorem, right? Now, this theorem that we're going to use is right here. The angle formed between a chord and its tangent equals the opposite interior angle, right? So A and the opposite angle A. B and the opposite angle is B, right? So good. So a tangent and a chord. See, that's a chord from from end to end in the circle. So M is here, so M must be equal to N. No, I'm sorry. This is opposite angle. I do have to pull it. This is opposite angle right there, 61 degrees. So now this is 61, right? Opposite interior angle. I get this is N. This is a radius, that's a radius. So this is another isosceles triangle, right? Let's do it like this. Because these two lines are the same. All right. So now I get N, and this must be also N. So once again, I get 61 plus 2N is equal to 180. Subtract 61 from both sides, I get 2N is equal to 119. Divide by 2, I get N is equal to 59.2 degrees. So N is equal to 59.5 degrees. Sorry about that, 0.5 degrees. My bad. All right. A regular polygon has interior angles of 135. Calculate the number of sides the polygon has. So now, one thing that we know is that the interior angle plus the exterior angle adds up to 180 because they are angles on a straight line. If the interior angle is 135, each exterior angle must be 45 because this is a regular polygon, meaning that all sides and all angles, interior angles and exterior angles, are the same size. Now, the interesting thing about every polygon, the exterior angles only add up to 360 always. I don't care how much sides it has. So to find the number of sides is 360 divided by each exterior angle. So this is an 8-sided polygon. Now, continuing on, I have forgotten to do this one, but a previous video that I had sent, 2012, paper 3, number 5. I forgot to answer part B, right? A regular polygon. Now, before we answer the next question, I'm going to do a quick thing. The sum of the interior angles of a triangle adds up to 180, right? One triangle. Of any quadrilateral, meaning a four-sided shape, is I can form two triangles, so it's 180 times 2, so it's going to be 360, right? Good. Now, for a pentagon, I've got 5 sides. I can form 1, 2, 3 triangles, so it's 180 times 3. Now, if you notice something here, this number here, the 3, 2, and the 1, is 2 less than the number of sides. So the sum of the interior angles is also equal to the number of sides minus 2 times 180, right? But you can derive this formula by trial and error, all right? So now, looking at that, now let's answer this. A regular polygon has 15 sides, so n is equal to 15. So how much triangles do I have? I've got triangles. I've got 15 minus 2. I can form 13 triangles. And if each triangle is 180, okay, so I can say that each triangle is 180. So 15 minus 2 is going to be 13 times 180 is going to be 2,340 degrees. Each interior angle is equal to this number you just found divided by the number of interior angles. The number of interior angles is equal to the number of sides. So each interior angle is 156 degrees. Be blessed.